Alright, welcome. And now what we're going to talk about are transformations. So before we get into the different types of transformations for graphs, we need to first understand the basic functions that we're going to be dealing with. Now, they were also called parent functions. These are, so remember that, parent functions. These are some of the parent functions. There's one that I couldn't list. I'll list that last. And I'll talk about that in a moment. But these, and that's the reciprocal function. But there are these 9 functions, right? So we've talked about linear and constant functions, so we know what those look like. But the other 7 functions that we're going to talk about are these here plus the reciprocal function. So these are parent functions, or what I call the basic toolbox functions, because all of the transformations that we're going to talk about, as long as you understand the behavior and the shape of the basic functions, then and you understand what the transformations do to these functions, then you can graph any of the functions that we're going to talk about, because all of the functions you're going to be given are going to be some transformation of these basic functions. Okay? So again, we've got the linear function, which is mx plus b, and then of course we've got the constant function, which is a horizontal line, so that's where x is 0, or excuse me, where the slope is 0, right? So there's no x value, so it's just f of x equal to b. So all there is a y-intercept, right? And the identity function. The identity function is a line that goes straight through the origin, that goes at a 45-degree angle, and it's all the values where y equals x. So all the values where x and y are equal. Okay? And then we've got the quadratic. This is the basic parabola, right? So this is where we get our parabolas from, the quadratic form, and this is the most basic quadratic function. So it's a parabola that basically goes through the origin and opens upward. The vertex is at the origin. Okay? And then we have the cubic function, the cube function here. So it's the basic cubic function is x cubed. And so it has this sort of sideways S-shaped form. So it's sort of like a parabola. It's sort of like it's parabola, but you kind of swing the other side down. So it just flips downward. So you get this kind of like curved shape. So so that's the cube function, the basic cube function. And then we have the square root function, which is like a sideways parabola. So if you were to take this and go 90 degrees, and then of course this is only positive value or non-negative values, so it's only going to be the top half of the sideways parabola. Okay? And then similarly, just like with the cube function, we have the cube root function, which is sort of like the sideways S. So you can kind of see how this is flipped 90 degrees and then flipped to get this. And then of course the absolute value function. So this is the basic absolute value of x, which basically takes the identity function and it takes this part here because it's always positive. So it's taking all the negative values of x and flipping them up to the other side. So that's another way of looking at the absolute value function. So, but it makes this V shape, right? So each one of these is going up at a 45-degree angle from the x-axis. Okay, and then the last one is the reciprocal function. Okay, and I'll do that one right here. And that's f of x equal to 1 over x, right? So how does this one behave? Well, as x goes to 0 positive on the positive side, as you approach 0 here, this is going off to positive infinity. And as x goes to positive infinity, this is getting closer and closer to 0. So this does something like this. Okay? Now, if x is negative and close to 0, this is really, really big. But it's still negative. So it's, as we get closer to 0, it's going downward. As x gets really large negative, so as we go out this way, x is getting, or this whole thing, the function is getting close to 0. So it's doing that sort of thing. So this is what the reciprocal function looks like. It has this little curve here, like an exponential decay curve here, and it's got this flip across the origin. So that's the reciprocal function. So these are the basic functions that we're going to be studying. You want to memorize these, you want to know how these behave, and you want to know what the basic function graph looks like, because that's going to help you. And also, I would strongly recommend, make sure you know how to graph 3 points on these, right? Where like 3 different points that you can graph, okay? 3 different points, or on the straight line, 2 points, right? And so just understand how these behave. Graph 3 points on a curve, right? And so if you know how what the transformations do to those 3 points, 2 or 3 points, then you can get an idea of what the graph of the transformation is going to look like. Okay? And we'll do examples of that too. Have a great day.